In part B1, we're given some information to allow us to calculate the value of the corner ratio of a geometric series. In the first instance, the sum to infinity of a geometric series with first term a and corner ratio r is 10. So if you just remember from our previous question, the sum to infinity is a over 1 minus r. So in the first instance, we're going to have 10 is equal to a over 1 minus r. And then we have a second sum to infinity with first term a again, but corner ratio 2r. And this sums to 15. So a over 1 minus 2r. Here you can see that we have two equations with two unknowns. So if we just rearrange them to make them a little easier to use, multiply by 1 minus r on both sides here, we can immediately see that our a is equal to 10 brackets 1 minus r. And I'm going to substitute that straight into this equation here. So I end up with 15 is equal to 10 brackets 1 minus r over 1 minus 2r. And what I'm going to do now is multiply both sides by 1 minus 2r, giving me 15, 1 minus 2r is equal to 10 lots of 1 minus r. Now I could multiply these out by 15 and 10, but the easiest thing to do first of all would be to divide through by 5, leaving me with 3 brackets 1 minus 2r is equal to 2 brackets 1 minus r. Expanding out now makes our lives a bit easier. We can see now that we have an equation just with r in. Bringing our numbers over to the left hand side by subtracting 2 and our r's over to the right hand side by adding 6, we can see that 1 is equal to 4r. So 1 quarter is equal to r, or 0.25 is equal to r. Now that we have r, it's a fairly straightforward calculation if we wanted to go on and calculate a.